Given a language L defined, there is some kind of recursion concept here, just like an algorithm where L power I is defined, where L power 0 is epsilon, L power 1 is defined as L power I minus 1 followed by L for every I greater than 0. Now the order of a language is defined as the smallest k such that L power k is equal to L power k plus 1. So you need to find something like this. Now first you will try L power 0 is equal to L power 1. So k plus 1, right? If satisfied for this, then answer is going to be 0. Order of L is going to be defined as the smallest k. But if it is not equal, then you will find L power 1 which will be equal to L power 2. If this is satisfied, first one is not satisfied but second one is satisfied, then order of L is 1. If this is also not satisfied, you need to find L power 2 is equal to L power 3. If this is satisfied, then order of L is 2. So you need to find is the order of L is 0 or order of L is 1 or order of L is 2. So to find the smallest k in this fashion. So here k value is 0, here k value is 1, here k value is 2. So which k value this L powers are satisfied? Let's find out for the given motion which L power satisfies the smallest k. Now let's start with this motion. This motion is accepting some language, so it is considered as L1. So why do you want L1? Just take L, because as your definition is also with L, so better to follow L. So now for order of L1, I am just assuming order of L only. And now accepted by the following automaton, the order of L is dash. So L1 and L both are same, assume that. So now I am assuming that L here same as L1. So what is L here? So L is accepting, L is nothing but epsilon followed by, you see that 0 followed by any number of that even zeros, 0 followed by even zeros. So that makes odd 0, right? Epsilon or, so 0 is accepted followed by any even zeros. That means it will become total 0 followed by double 0 will become odd. So 1 0 accepted, then 1 0 followed by double 0 or 1 0 followed by 4 zeros and so on. So this is a language given by or represented by the finite automata. Now this is what it is given by the motion. Now you need to apply the algorithm. What is L power 0? What is L power 0? L power 0 is by definition epsilon. You cannot change it. So let's take it as same. Then what is L power 1? Apply the definition, that's L power 0 dot L. Now L is your motion L1 representation and L is here, L power 0 is epsilon. So we will substitute epsilon dot L is already here. What is L? Epsilon plus 0 0 whole star. And you know that epsilon dot is L is always L. So which is same as just L. So I am writing it is L. Okay. Epsilon dot L is L. So L0, L1 when you compare, right? So this is not matching. So definitely you should go for down. So L power 0 not equal to L power 1. So because here L power 0 is epsilon and L is something different. Now let's try for L power 2. L power 2 is a definition is L power 2 minus 1, that is 1 dot L. What is L power 1? Is same as L, right? So L dot L you are writing L dot L. So what is L dot L? You need to understand what is L dot L. So when you take this twice, what happens? See that epsilon plus 0 0 whole star, and this is one L, and another L is epsilon 0 followed by double 0 whole star. If you carefully observe this, can you generate epsilon? Yes, epsilon followed by epsilon, epsilon. Can you generate 1 0? How? Epsilon you can take from here, you can take 1 0 from here. Can you generate double 0? 1 0 from here, 1 0 from here. So if you observe it, it can generate 0 star. So this LL is equal to 0 star. So all the strings over 0 can be generated with the help of LL. So now L power 2 you got a 0 star, L power 1 you got L, but L power 1 and L power 2 are not same, because L power 1 is same as L and L power 2 is 0 star, and 0 star is a superset of basically L. So even this is failed. So you cannot say order of L1 is K. Order of L1 you can't say 1. So now the next one, L power 3 we try. L power 3 is nothing but L power 2 dot L. L power 2 we got a 0 star, and L is you have epsilon plus 0 followed by double 0 whole star. Now you decide, see here already epsilon is there, so 0 star dot epsilon you can get a 0 star, and 0 star dot anything, 0 star union any set of strings is always 0 star. So this is equal to 0 star. Now you observe L power 2 same as L power 3, it is true. So order of L definitely 2 here. As the smallest this 2 you are going to take this 2, because order of this L power k is equal to L power k plus 1, then order of L is answered as k, right? So order of L is equal to 2. Now for this the answer is order of the L1 is going to be